114, 5.1, adding and subtracting polynomials. Objective 1, understand the vocabulary used to describe polynomials. A polynomial is a single term or the sum of two or more terms, like the one right there, which has more than, this is one term, this is another term, and so on. Containing variables with whole numbers. This polynomial contains four terms, 1, 2, 3, 4. It is customary to write the terms in order of descending powers. What this is meaning is, this is to the fourth power, third power, power to the first, and finally, technically, this is x to the 0 powers, thus the last. This is the standard form of a polynomial. Here are two other polynomials which are written in standard form, which is similar like the one we have there. Degree of ax of n. If a does not equal 0, the degree of ax to the n is n. Meaning power. This is considered degree 3 because it's exponent 3. The variable has exponent 3. This is considered degree 2 because the variable has degree power 2. Degree 1 because the variable has degree 1. And this is a constant, degree of non-zero. The degree of a polynomial is the degree of its highest order term. So we put this in order. The highest one is 3, so this is considered degree 3. The highest power of this one is 4, so degree polynomial 4. We have other terms, monomial, binomial, trinomial. Example, this is a trinomial because it has 3 terms, and it's degree 4 because the highest exponent in a variable is 4. Identify the polynomial as a monomial, binomial, or trinomial. Give the degree. So again, this has 3 terms, so this is a trinomial, and the highest degree is 5 because the highest power in the variables is a 5. Adding and subtracting. Adding polynomials are adding by removing the parentheses that surround each polynomial, if any, and then combining like terms. Like this. This is a bit too much, but this is the correct way. So polynomials are added by combining like terms. Like terms are terms containing exactly the same variable to the same power. So this is x squared, this is x squared. They're considered like terms. So you can combine them, adding them together, or subtracting them if needed. And then that becomes 10x squared. So let's see an example of this. We have negative 7x cubed plus 6x squared minus 11x plus 13 plus 19x cubed minus 11x squared plus 7x minus 17. Thus, even if we don't have anything, we have a positive right there. Let's make it a little bit more like this. So we're going to distribute that positive to each and every single one. Remember, that's a positive 1. So a positive times a negative gives me negative 1 times 7, negative 7x cubed plus 6x squared, because a positive times a positive times a negative is a negative 11x. Positive times a positive is positive 13. Now, I'm also going to distribute this. So positive times a positive gives me 19x cubed. So positive 19x cubed minus 11x squared, because a positive times a negative is negative. A positive times a positive is positive, and a positive times a negative is a negative 17. Now we need to see if we have like terms. We have 7x cubed and a 19x cubed. We have a 6x squared, so I have an 11x squared. I have an 11x, 7x. And we have a constant by itself, which is these. So, negative 7x plus 19x cubed, it's going to give me, let's get a calculator for that, just not to struggle. So I have negative 7 plus 19 equals 12x cubed. I'm done with those two. 6 minus 11 minus 5x squared. I'm done with those two. Negative 11 plus 7 minus 4x. And 13 minus 17 is negative 4. Let's do another one. Again, this is plus 1, so we're just going to distribute everything. Positive, okay, distribute here too. So let's start. A positive times a negative is 11x cubed negative. A positive times a positive is plus 7x squared. A positive times a negative, it's a negative 11x. A positive times a negative, it's a negative 5. A positive times a positive is plus 16x cubed. A positive times a negative is negative 3x squared. A positive times a positive is positive 3x. And a positive times a negative, negative 15. Like terms, so x cubed, 16x cubed, 7x squared, negative 3x squared, 11x plus 3x, and negative 5 and negative 15. So negative 11 plus 16 equals 5x cubed. 7 minus 3 is positive 4x squared. Negative 11 plus 3 is negative 8x. And negative 5 minus 15, negative 20. And that would be my solution for that one. Subtracting polynomials is exactly the same thing, except now instead of a plus, we have a minus in between the first and the second parentheses. So they must be the polynomials, subtract two polynomials at the first polynomial. This is the opposite to, that's too much work. So we have this. So it says 3x cubed minus 8x squared minus 5x plus 6 from 10x cubed minus 5x squared plus 7x. Okay. So we have 10x cubed minus 5x squared plus 7x minus 2. This is my first term. I'm subtracting, so that's a minus. 3x cubed minus 8x squared minus 5x. Let's make that a little bit smaller so we fit better. Resize. Move it a little bit, and there we go. Plus 6. Okay. So this first part over here, it's a plus 1. So it's still 10x cubed minus 5x squared plus 7x minus 2. This one I'm going to distribute. And we're going to get opposite signs. So it's negative 3x cubed. Why? A negative times a positive, it's negative. Negative times a negative is a positive. Negative times a negative is a positive. Negative times a positive is a negative. Like terms, 5x squared with 8x squared. 8x cubed with this. And constant with a constant. So 10 minus 3 is 7x cubed. Negative 5 plus 8x, negative 5x squared minus 8x, negative 5x squared plus 8x squared is positive 3x squared. Plus 7x plus 5x is plus 13x. Minus 2 minus 6 is negative 8. Graph equations by polynomials of degree 2. Graphs of equation defined by polynomials of degree 2, such as y equals x squared minus 4, have a mirror-like quality. We can obtain their graphs shaped like bowls, inverted bowls, using two-point plotting method for graphing an equation of two variables. So what it's telling us to use is plot method. So we're going to do our little table. But before we would do only 1 or 2 points, because that would be a line. This is not a line. So we need more than that. So let's do -2, -1, 0, 1, and 2. So I have y equals -2 squared minus 1. That's going to give me y equals 4 minus 1, which equals 3. That was for this. Then for this I have y equals -1 squared minus 1. It's 1 minus 1 is equal to 0. So I have y equals 0 squared minus 1. So I have y is equal to -1. Then I'm going to be using y equals 1 squared minus 1 equals 0 minus 1, which equals y equals 1. And finally, for this one, we're going to use that. Now, if you notice, this and this have the same y. This and this have the same y. So that's what this was telling you a minute ago, that they have mirror-like qualities. Okay? So if we graph this, so I'm going to copy this and take it to the other page. Copy. Paste. So I'm going to have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I'm going to have -2 and 3. -1, 0. 0, -1. That should have been 0. 0 and 2 and 3. And this is what it says that it's a cup.